The night air in rural France during June of 1944 was thick with tension, a darkness that concealed both the occupiers and those who sought to dismantle their grip on the continent. Along a lonely stretch of country road, a German supply convoy rumbled through the gloom, its engines laboring under the weight of ammunition, fuel, and desperate reinforcements. The drivers, exhausted and on edge, kept their headlights dimmed to mere slits, a necessary precaution against the prowling Allied air patrols that dominated the skies above. The convoy was a lifeline, a steel artery pumping vital blood to the Wehrmacht's defensive lines in Normandy. Suddenly, the rhythm of the march was shattered not by the roar of a fighter-bomber or the thunder of artillery, but by a sharp, violent hiss followed by the sickening thud of a rim hitting asphalt. The lead truck swerved, its tires shredded by something unseen in the dark. Moments later, the second truck suffered the same fate, then the third. Within minutes, the orderly procession of military might was reduced to a chaotic traffic jam, stranded in hostile territory, bleeding air from ruined rubber. When the drivers and guards dismounted to inspect the damage, they found the culprits scattered across the road like deadly metallic seeds. They were small, twisted pieces of metal, roughly the size of a man's fist, engineered with a cruel and ancient geometric perfection. No matter how they landed, one sharpened steel spike always pointed vertically, waiting for the pressure of a pneumatic tire. This was medieval technology resurrected for the industrial age, a weapon of paralysis delivered by the British Special Operations Executive to bring the German war machine to a grinding halt. This device was known as the caltrop, though in the summer of 1944, the Germans would come to regard it as a plague upon their logistics. The British engineers at the Special Operations Executive, or SOE, had reached back through the annals of military history, bypassing the age of gunpowder to find a weapon design that had served Roman legions and medieval armies. The concept was simple: denial of movement. But where the Romans had used caltrops to maim the hooves of cavalry horses and slow the advance of infantry, the British adapted them to destroy the Achilles heel of a modern mechanized army, the pneumatic tyre. These devices cost pennies to manufacture, required absolutely no maintenance, and were light enough that thousands could be packed into a single supply canister dropped by parachute. According to French regional archives, resistance fighters seized upon this simple tool with enthusiasm, spreading them across every major road network in northern France. It was a campaign of friction, a strategy designed to turn the occupiers' own infrastructure against them. The SOE designated this operation Plan Tortue, or Plan Tortoise, a fitting name for a strategy intended to slow the enemy's rapid response capabilities to a literal crawl. The brilliance of the plan lay not in the destruction of tanks, which required heavy weaponry, but in the neutralization of the trucks that supplied them. Germany's fundamental problem in occupied France following the Allied landings on June 6 was one of distance and time. The Atlantic Wall had been breached, and to contain the bridgehead, the Wehrmacht needed to move reinforcements from across France and beyond. These troops, along with their ammunition, fuel, and rations, had to travel hundreds of kilometers by road and rail to reach the fighting front. Every kilometer of French asphalt represented a vulnerability, a chance for the resistance to extract a price in time. The resistance leadership and their British handlers understood that traditional sabotage, while effective, had high barriers to entry. Blowing up a bridge or cutting a railway line required explosives, timing devices, detonators, and, most importantly, technical expertise. It was dangerous work that required training and planning. Bridges were heavily guarded, and railway tracks, even when severed, could often be repaired by efficient German engineering crews within hours. To truly paralyze the transport network, SOE needed something simpler. They needed a weapon that required zero training, something that a local farmer, a shopkeeper, or a teenager could deploy in seconds and retrieve just as quickly if a patrol appeared. They needed a weapon of opportunity, and the caltrop was the perfect solution. The development of this modernized ancient weapon took place in the quiet, manicured grounds of the Frythe mansion near Welwyn Garden City, a location that belied the deadly serious nature of the work conducted within. This was Station 9, the SOE's primary research and development facility, officially designated on the 19th of July 1940. Under the command of Lieutenant Colonel John Dolphin, and with scientific research led by Professor D.M. Newitt, the station was a hive of eccentric innovation. Their mandate was incredibly specific and demanding. Create equipment that was light enough to be dropped from an aircraft, durable enough to survive the impact of landing, simple enough for untrained French civilians to use effectively, and, crucially, impossible to trace back to British factories. The caltrop met every single one of these criteria with flying colors. It was the embodiment of the SOE's philosophy of asymmetric warfare. Imperial War Museum records detail the specifications of the standard SOE Type 4 caltrop, noting its dimensions as 59 mm by 59 mm by 51 mm. It was a solid metal construction based on tetrahedral geometry, a shape that guaranteed a spike would always face upward. It was a mathematical certainty weaponized for sabotage. While the British perfected their solid steel design, their allies across the Atlantic were developing their own variations. The American Office of Strategic Services, the OSS, created a version that was slightly larger, measuring 8.6 centimeters per side. The Americans added a sinister innovation to the ancient design: hollow spikes. The logic was that if a solid spike pierced a tyre, the rubber might seal around the metal, slowing the leak. A hollow spike, however, acted like a hypodermic needle, allowing the pressurized air to escape rapidly even if the point became blocked by soft ground or the tyre material itself. Dr. Stanley Lovell, the Director of Research and Development for the OSS, famously described the caltrop as the simplest weapon they ever made. It was a testament to the idea that sophistication in warfare does not always equal complexity. Sometimes, the most effective tool is a jagged piece of metal thrown in the dark. Station 9's ingenuity regarding tyre sabotage did not stop at the caltrop. For agents operating in more permissive environments, where stealth was paramount and a pocket-sized tool was necessary, they developed the coin-type tyre slasher. This device, examples of which are now held in the Imperial War Museum collection, was a marvel of concealed carry engineering. Measuring just 58 mm by 37 mm and only 5 mm thick, it was constructed as a steel disc with a knurled edge to provide grip. To the casual observer, or a German soldier conducting a hasty search at a checkpoint, it resembled a large coin or perhaps a benign tool. However, it concealed a short, curved blade that could be deployed by a lever. An operative could walk past a parked staff car, kneel as if to tie a shoelace, and use the device to silently destroy a tyre. One such device was issued to Wing Commander FFE Yeo Thomas, the legendary White Rabbit, before his harrowing missions into occupied France. Another variant, the Dagger Jack DB clasp knife, offered a dual-purpose solution. Measuring 122 mm when closed, it featured a claw-shaped tyre slasher blade at the pommel, allowing a resistance fighter to slash a tyre with a raking motion. Crucially, all these designs were manufactured sterile. They carried no serial numbers, no maker's marks, and no stamps that could identify their country of origin. If found on a captured partisan, the device offered no intelligence value to the Gestapo. The industrial scale of this sabotage effort was handled by Station 12 at Aston House near Stevenage. Commanded by Colonel Leslie J. Cardew Wood, this facility was the logistical heart of the SOE's supply chain. Historians have often described Wood and his facility as a strong contender for the inspiration behind the fictional Q branch in the James Bond novels. It was a place where deadly gadgets were boxed, crated, and prepared for clandestine delivery. By late 1942, the tempo of operations was immense, with 2 or 3 lorries departing the facility every single day, loaded with equipment destined for the cargo holds of waiting aircraft. While the production records for items like time delay detonators, over 12 million produced, and L-delay switches are precise, the specific production figures for caltrops remain classified or were lost to the chaos of the era. However, the nature of the device suggests the numbers were staggering. They required minimal raw materials and could be stamped out by any competent metalworking shop, allowing production to be decentralized and massive. Getting these supplies from the factories of England to the ditches and barns of rural France was a feat of logistics in itself. The primary delivery method was the parachute drop, utilizing the CLE canister. The Mark I container was a rugged cylinder measuring 1.7 meters long and 40 centimeters in diameter, with a capacity of approximately 159 kilograms. These canisters were the lifeline of the resistance, packed with everything from Sten guns and plastic explosives to chocolate, socks, and thousands of caltrops. The primary departure point for these clandestine flights was RAF Tempsford, a secret airfield that became the hub of SOE air operations. The heavy lifting was done by Halifax bombers, which could carry 15 containers per sortie, and the Sterling Mark IV aircraft, which could manage 20. The total volume of material delivered to France is mind-boggling: 10,000 tons of equipment in total, with 4,000 tons dropped before the invasion to prepare the ground, and 6,000 tons dropped after D-Day to sustain the uprising. By June of 1944, the airwaves were just as busy as the skies, with 50 wireless links connecting London to the various French resistance movements, coordinating the drops and the targets. The culmination of this preparation came in the first week of June 1944. Plan Tortue was activated on the 5th and 6th of June, triggered by a stream of coded, personal messages broadcast by the BBC. Among the cryptic phrases that floated over the radio waves was, "It is hot in Suez," and "The dice are on the table." To the uninitiated, they were nonsense. To the resistance cells huddled around clandestine radios, they were the command to unleash chaos. French regional archives from the Allier department record the immediate aftermath, noting that numerous tire puncture devices were spread on the main roads of the department. The report states simply that the resistance did not fail to sew special nails on the roads. In Sector 146 near Saint-Quentin, the documentation shows a coordinated effort where fighters spread caltrops and simultaneously removed road signs. The result was a logistical nightmare for the Germans. Convoys would get lost, backtrack, hit caltrops, suffer tire blowouts, and sit vulnerable in the open countryside, unsure of their location and unable to move. Perhaps the most famous and debated example of transport sabotage affecting German operations was the delay imposed on the 2nd SS Panzer Division, Das Reich. This elite, battle-hardened division was stationed near Montauban in southern France when the invasion began. They were desperately needed in Normandy to push the Allies back into the sea. The journey north should have taken a motorized division 3 days. Instead, it took them 17 days to reach the front. SOE's own after-action reports were triumphant, stating that the extra fortnight's delay imposed on what should have been a 3-day journey may well have been of decisive importance for the successful securing of the Normandy bridgehead. It is a compelling narrative, one of scrappy resistance fighters stopping tanks with bent metal. However, historical accuracy requires a nuanced view. While caltrops played a role, they were part of a larger symphony of destruction. Tony Brooks's Pimento circuit focused heavily on railway sabotage, using SOE-supplied abrasive powder to ruin the axle bearings of flat cars intended to carry the tanks. When the Germans were forced onto the roads, they faced felled trees, ambushes by Maquis units, and devastating airstrikes by the Royal Air Force, often directed by SAS teams on the ground. The Imperial War Museum catalogue notes that while caltrops were devastating to trucks, the small, coin-type slashers would have been of doubtful utility against the thick-walled, run-flat tires of heavy military vehicles. Caltrops worked best against the softer targets. The staff cars, the requisitioned civilian trucks, and the supply lorries that kept the division fed and fueled. The German reaction to this campaign of sabotage was swift and brutal. They attempted countermeasures, employing convoy escorts and sweeping routes before moving heavy equipment, but the sheer ubiquity of the caltrops made total security impossible. Frustrated and delayed, the German command turned their rage on the local population. General Otto von Stulpnagel had announced as early as September 1940 that no mercy would be granted to saboteurs, but by 1944, the policy had evolved into mass retribution. The passage of the Das Reich Division through the Limousin region, an area the Germans called Little Russia due to the intensity of resistance activity, was marked by atrocities. On June 9, in Toul, 99 civilians were hanged from balconies and lamp posts. On June 10, at Oradour-sur-Glane, 642 civilians were massacred, and the